Is giving a recursive definition for an arithmetic sequence. You can see it tells me here that the very first term in that sequence, a sub 1, is the number 55. And then this also says, hey, if you want the next term in the sequence, take the current term, right? That's what that means, the current term, and subtract 10 from it. Again, if you're sitting at a spot, the next term is the current term minus 10. Well, thinking about that, we can now write the first four terms. Here's the first term, right? We were told that that's 55. And then it says the next term, right? The n plus 1 term is the current term, 55 minus 10. That looks like we're going to be at 45. The next one's going to be 45 minus 10. And the one after that will be 35 minus 10. So those are the first four terms of our sequence, and then we just continue subtracting 10 each time. By the way, that number 10 is our common ratio. It's how much we're going down by each time. Write an explicit equation for this particular sequence. Well, one of the things we need to know is we need to know what the zero term is, right? It's not part of the sequence, but it's the one that's over here, right? Well, if I'm subtracting by 10 each time to move forward, if I want to go back to the zeroth term, I would just add 10. So here's my zero term. It's the number 65. And again, each time we're subtracting 10, that common difference, that repeated addition or repeated subtraction is shown with the operation of multiplication. So for an arithmetic sequence, what we're looking at here is something like, I'll say, the value of this sequence at any particular value n is 65 minus 10 times n. That would work just fine. Right, so if I want to know what the first term is, right, when this is the number 1, the first term, you can see I would put a 1 in, and 65 minus a single 10, minus 1 10, would be 55. If I wanted to know the second term in the sequence, right, I would put the number 2 in for n, and 65 minus 2 10s, right, minus 10 and then another 10, or minus 20, gives me 45. So this is exactly how we show repeated subtraction, right? I'm subtracting by 10, 1, 2, 3 times to get the third term, and 65 minus 10 minus 10 minus 10, or 65 minus 30, is 35. So it's a beautiful explicit equation for that particular sequence.